So part A of this question asks us to find the coordinates of the local minimum point where f of x, the function shown here, is negative 2x cubed plus 5.1x squared plus 3.6x minus 0.4. So what we're first going to do is differentiate the function since it's looking for a stationary point. So differentiating it gives us, using the power rule, negative 6x squared plus 10.2x plus 3.6. And if we equate this to 0, we get negative 6x squared plus 10.2x plus 3.6 is equal to 0. We can use the quadratic formula to solve for the values of x where this is a minimum or maximum. So x is equal to negative b, which is negative 10.2, plus minus the square root of b squared, which is 10.2 squared, minus 4 times 3.6 times negative 6. Divided by 2 times a, which is negative 6. Just gives us negative 10.2, plus minus square root of, now I'm going to simplify the thing in the bracket, minus 4 times 3.6 times negative 6. So that's 190.44 divided by negative 2 times negative 6, which is negative 12. And if we just put this into our calculator, we get, so for the positive answer, when this here is positive, the answer is plus square root of 190.44 divided by negative 12. Well, this is actually the negative answer, sorry, because this one's negative. So the answer is negative 0.3. Now for the other solution, when we use a negative sign, this is going to be positive just because we're doing negative divided by negative, which gives you a positive value. So negative 10.2 minus the square root of 190.44 divided by negative 12, and that gives us 2. So these are the two stationary values of the function. However, we can see they want the minimum, and the minimum here seems to exist to the left of the y-axis, so it's a negative value. So we're going to take negative 0.3. And when x is negative 0.3, we can just substitute it back into the original equation to find the corresponding y value, which gives us, just putting it into my calculator, plus 3.6 times negative 0.3 minus 0.4. Sorry, just give me a second while I put that in. Plus 5.1 times negative 0.3 squared plus 3.6 times negative 0.3 minus 0.4. That gives us negative 0.967. So for part A, this is our answer. Okay, and now we're going to move on to part B. So the graph of f is translated to the graph of g by the vector 0k. Find all values of k so that g of x is equal to 0 and has exactly one solution. So the vector 0k is basically moving k units up because vectors are structured in terms of x coordinate, y coordinate. So the x is 0, which means you're not moving it horizontally at all, but since the y is k, you're moving it up k units. So given this, we have to figure out, well, what part of the, if we move it up k units, which solution will still exist? We're getting rid of 2 solutions and leaving only 1 because right now we have 3. If you look at the function right now, we have 1, 2, 3 solutions. However, we can see that if we lift the function up, these 2 solutions can lift above the x-axis. This solution over here, since it's a continued downward trajectory, will remain, but these 2 solutions, since they're bound by a minimum point which can move up, these ones can disappear. So we have to figure out at what point does this minimum point go above the x-axis. But that's simple because we know that the y value is negative 0.967, which means that it is negative 0.967 units under the x-axis. So if we lift the function up by 0.967 units, it will just barely touch the x-axis. This means that if k is greater than 0.967, then we've lifted the function completely above the x-axis. So our answer is k is greater than 0.967 units, because that's the point where this minimum point is above the x-axis and only this solution remains. But just 1 second, that's just one solution. The other solution is, yes, if we move this down further enough that this drops below the x-axis, the only solution will be this one over here. Because this graph will look something like, and as you can see, it only crosses the x-axis once. So what we have to know, is what is a y-coordinate of this? And basically, if we ensure that it drops by more than that y-coordinate, then we've successfully only obtained one solution. So we know that the maximum of this function, as obtained by the quadratic formula, is 2. So when we find f of 2, which is the corresponding y-coordinate, we get 2 times 2 cubed plus 5.1 times 2 squared plus 3.6 times 2 minus 0.4, which is equal to 16 plus 5.1 times 4 plus 7.2 minus 0.4. Negative 16. So negative 16 plus 5.1 times 4 plus 3.6 times 2 minus 0.4, which is equal to 11.2. So this coordinate here is 11.2, which means that the other solution is if k is less than negative 11.2. Because remember, this is a vector, so if you're going down, the y-coordinate has to be negative. And if it's less than negative 11.2, which means it's basically like negative 12 or something, then it's dropped further than the x-axis. So these are our two intervals that we must be aware of when considering this question. It's an easy thing to miss out, but one that we must be very aware of.